Welcome to Module 9, Matrix Algebra. Matrix algebra is used extensively in engineering, in dynamics, vibration, automatic control, kinematics of mechanism, etc. In this module, we'll go over basic operations of vector and matrix manipulations, including dot and cross product, transpose, determinant, inverse. Also, we will briefly discuss of solving simultaneous linear equations by matrix operation. Lastly, we will introduce some special matrices commonly used in different engineering problems. The transpose operator changes the rows and columns of matrix, and it can be done simply by putting single quote after a matrix variable. As shown here, row vector becomes a column vector after the transpose or vice versa. Another example shows that transpose operation for the complex number matrix will do two things. For each element, it will do the complex conjugate and transpose. However, if you put the period in front of this transpose, it will do just the transpose, not conjugate. Next, we will learn how to do a dot product of two vectors in MATLAB. Geometrically, the dot product of two vectors produce a orthogonal projection of one vector to the other, as shown here, with its magnitude of a times b and cosine theta. Theta is the angle between vector a and b. As shown here, dot product of two vectors a and b can be obtained by element multiplication and add them together. It can be done in MATLAB like this. Dot product of vector a and b can be done by using the command dot and parenthesis a, b. This can be done also by element multiplication, vector a times b, but this is a dot operation. Then it will give you this vector, which is multiplied by element. Then using the sum command, you can add them up. Then your C1 variable becomes 32. But all of this can be done also by the using simple command of dot. It should be noted that dot product is commutative, which means same output will be obtained by switching the sequence, which means dot product of AB is same as B dot product of A. This is an example of using dot product in mechanics. We often need to find the mass center of multiple masses to apply the Newton's equation. In mechanics, we assume that whole mass is concentrated in any tiny object located at the mass center. For the center of mass, this is the formula. In mechanics, for example, you have multiple masses. You can multiply each mass times its coordinate value and add them up and divide by total mass. So in this example, we're going to use the three different masses located at particular position into this space. Of course, the mass center will be located around in the middle here, but this can be found by this M file MATLAB code. First, what you need to do is you need to generate the vector mass, which has individual mass values. And you need to create vector x, which stores x coordinate of each mass. And vector y, which stores corresponding y coordinate of each mass. Here you should follow the order of this. In this program, we assume that order of the mass is 1 kilogram 1.52. So, which means this is mass 1, and this is mass 2, and this is mass 3. It is shown here, 1, 1.5, and 2. Then coordinate for their positions should follow the same sequence. So to find the mass center, as you can see here, numerator portion can be found by the dot product of mass vector and x coordinate vector divided by sum of vector mass. Same for the y coordinate. Dot product of mass times vector y and the summation of the mass. So now you can display its mass center position. So if you run this program by this green arrow, the program will output saying that your mass center is located at 8 and 9.1. So it will be around here. Another example of dot product is finding an angle between two vectors. In this particular example, two vectors are forces, and an angle between these forces can be obtained by dividing a dot product by the product of vector magnitude. So formula is here. The cosine theta can be obtained by dot product of two forces divided by their magnitude. So here this MATLAB program plot these two force vectors. So two force vectors are stored in the matrix force, and each row is the force 1 and force 2. So here this is force 1, this is force, and this is origin, and this is a force 2, which is stored in the second row. So our interest is how to find the angle between this. So in this program, from this matrix force, we defined force 1, force 2. You know that we just picked first row and the second row, and you remember plot 3 function, right? So you can plot those forces from the origin, and the force 1 x coordinate, and this is a force 2 y coordinate, and this is a force z coordinate with a line width of 2. So this small for loop is plotting two vectors. Please note that I used the hold is on command to plot first vector 1 or force 1, then hold command will hold the previous vector 1 plot, then vector 2 plot is added on it. So this is a good review of your plot 3. And next we just added grid and the labels. So next step is to implement this equation. So first you have to find the magnitude of force 1, which can be obtained by squaring the force 1 with the dot operation. Each xyz coordinate xyz component are squared and added and the square root. Same magnitude 2 is obtained in this way. After you find magnitude of each force, and you can apply this equation, which means that you do the dot product of force 1 and force 2 and divide by magnitude 1 and magnitude 2. So how determine the theta? Of course, you can use the A cosine, which is arc cosine. Then you know that answer is radian. So to print out your output like this, which is in degree, what you need to do is that you should divide your answer by 180 divided by pi. Also, if you want to get your theta in degree, you can use the A cosine D command, which will give you theta in the unit of degree.